User recognized. Door unlocked. User not recognized. Door locked.
Hello and welcome to FaceLock. I hope you enjoyed the somewhat jokey video at the start, but I think it did a good job of encapsulating what FaceLock is about as a project. It showed you how the system would deal with both an unrecognized user trying to unlock the door as well as a recognized user unlocking the door, and what it would be like to use in a home environment. So my plan for FaceLock was to essentially take the somewhat menial task of unlocking your door and introduce facial recognition to streamline the process and provide sort of a system that could be used by either a domestic household or a commercial sort of environment, because it provides you with statistics related to the access to the specific door. I wanted it to be able to run on have a back-end web server which talks to a database, so that the user could do what they wanted really with the application and sort of upload their own photo, add guests to the door and such, so that basically it would be a fully working application that could theoretically be pushed to the commercial environment. My main sort of inspirations for this project was the Ring doorbell, which I'm sure you all have heard of. Is a video doorbell which sits on the outside of your house, and it uses sort of motion detection to give feedback to the user on what's going on around their door, etc., and sends push notifications to the user on basically just everything that's happening, whether someone's at their door, etc. However, the main difference between this and FaceLock is that FaceLock does all of that functionality as well as using facial recognition, which Ring doorbell doesn't, to unlock the door. So really, FaceLock is a more well-rounded application. So if I draw your attention to the FaceLock webpage, this is what a user is greeted with the first time they'll go to the page. And it's just simple, asks the user to either register or log in. And as you can see, I've got AuthGuard set up, which means, because I use JavaScript web tokens on the web page, which means if when a user logs in, they're assigned with a token, which basically stores sessions. So if a user isn't logged in, they can't visit the relevant pages. It will just redirect them back to the login page, so they can't get onto pages that I don't want them to get onto without an account. So for now, I do have the registered page here, but for now, to show sort of statistics and stuff, I'll use a pre-registered account, and then at the end of the video, I'll show you the creation and the steps that were taken by a new registered user. So for now, I'll just log in, and I'll log in as Carthew1, which is the user I've set up, and then my password. So this uses salted and hashed passwords stored in the database, just for an added level of security. So when the user logs in, this is the page they're greeted with, and this is the dashboard page. Just reload it there quickly to show you. The dashboard page which shows stats about the user's account. So we have unlocks today, which is 47, and this is just when the facial recognition software runs on the virtual machine that I have. Every time a user is recognized, in this instance it's me, it will update this tally. So yeah, and then the second stat is unrecognized users. So every time there is a user which hasn't got their encoding associated with my account comes to the door, it will show this as an unrecognized user and update this stat here. And then I have the last unlock time, which is just simply a timestamp of when the door was last unlocked. So whether it was by you or one of your trusted users, it will it will update this timestamp and show you the time that it was unlocked. And then this trusted user column is basically just how many users you have associated with your account. So say I wanted you to have access to my door, I'd add you as a trusted user, and then that stat would update to 4. And then I have a simple pie chart here, which uses chart.js and is collapsible, so all the things can be changed like this. And essentially what this shows is each user that's associated with my door. So here you can see I have me, my brother, my mum and my dad associated with my door. And the number of times they've also unlocked my door. So if we see I'm here, I've got 47, as you can see in the top left. And if I go to see my brother, who's his username's Carthew, you can see he's unlocked it 6 times. My mum 12, and my dad 3. So yeah, I thought this was just a nice way of visualizing, sort of an example of what can be done with this application. I want to be able to in the future have more statistics about the door, sort of the time each specific user's last access it, and maybe be able to customize this homepage or have a different stats page entirely, so they can just sort of get different aspects of what's happening on their system. So then the next tab is my guest tab, and this is where you can add and remove the users that you want to be able to access your door. So here it's all live updating. So if I wanted to remove my mum, just click remove there, and then she's removed from the system and she can no longer get into my door. And say I wanted to add her back, just enter her username here and click add, and you can see she's added back to the table. And that's also updated my list within my database table, which has a list of trusted users, so she'll have now been removed and then added back to that list. And so what happens is when I run the facial recognition software, which I'll show you in a minute, so essentially the door lock, it loads a list of facial encodings from this list, or from my trusted user list within the database, so they can then be recognized as well. I then have another tab, which is the live stream function, and this takes a live feed from the door lock, as you can see me here, and it replays it onto the web page so the user can see what's being displayed on the front door. And this uses WebRTC, which stands for Web Real-Time Communication, and this is a technology which is trusted by people such as Facebook and Google to do their sort of messaging communications. And at the moment I've just got it as a MPEG stream, but it does have, the technology does have ways of doing complete video communication, so that I can do a two-way audio stream, so basically a video call with the door lock, so I'll be able to talk to the user on the other end as well, which is what I ultimately want to do with this application. I then have a Twitter feed, which I just made a mock FaceLock account and just tweeted a few things from it, just to sort of show, because obviously social media integration is key for keeping users sort of engaged with the product. So yeah, I just thought it was a nice implementation to have on the website. And then this last tab on the left hand side is where I would go to upload a photo of myself. So when you create your account, you have no registered encodings. So what that means is you won't be able to access your door, so you'll need to go onto here to upload a photo of yourself, which then the facial recognition software uses on the door lock system to recognize you. So I won't do it for this one, but I'll show you it when I go through and create an account at the end. So yeah, essentially I've also implemented virus checking. So when the user uploads their file, before they can press upload, it uses a virus API called Virus Total. And what this does is it checks the file they're uploading for any viruses, and if it is detected that there is one, it will not let you upload the file. I thought that was just a nice added layer of security. So then, as well as this, I have a profile page which just shows you information about the user. So from here they can see their team members or the people that they can get in their door, etc. Yeah, so that's essentially it. And you can log out, and log out basically just wipes the token and takes you back to the main login page. So this web page is developed using the mean stack, which uses the Mongo database. Mongo is a NoSQL database, so it uses documents, and I found this quite nice and easily scalable for my application, as I only needed one table. It was just quite a nice way of doing it. And then it uses an Express server, so I've created endpoints on the Express server which link to the database. So you send requests from the web page to the Express server, and the server then deals with the requests and performs CRUD activities on the database based on what you have the endpoint doing. And then I also use Angular. So Angular is a framework for creating websites, which provides nice single page applications like you see here, and Node.js, which is the basically the thing that encapsulates all of that together. So then if I now show you to the facial recognition side of this, so this is the virtual machine that I have running the facial recognition software. Just log into this. So essentially, eventually I want this to be put onto a Raspberry Pi or something of that size. But there were limitations with this where I couldn't do it because of the computational power needed to do the facial recognition. I was getting less than 1 frame a second. So in reality, it couldn't it couldn't really meet the requirements that I felt were acceptable to be able to be used as a door lock. So in the future, I would like to use cloud computing to forward the video feed onto a web server, or just have it so that they press the button on the doorbell and it takes a picture of them and then uploads that to the cloud server, which can do the processing. So that will mean I can keep the form factor of the actual doorbell itself down. So on this door lock, I have a PHP script running as a daemon, which basically accepts incoming HTTP requests, which come from the web page. So that's how I upload the file. And that PHP then runs a Python file which does the encoding for the photos that you've sent over, and then uploads your encoding to the database. So for demonstration purposes, I have it so you have to run the code. So I have my door lock application Python file, and you then put in the username, which you want to run. So eventually, in the final application, I'll want it so that your door lock is specifically associated with you, and this would run on startup. So I will now run this and show you what happens. So this loads. I'm using OpenCV to show you a demonstration of what the door lock is seeing. So you can see that it's seeing me currently, and when it recognizes me in 20 frames, which is the criteria I have set, it'll print door unlocked. I did have plans to buy, or I did buy an electronic door lock that I could hook up to the laptop and would be able to unlock that and show you the actual process of the door unlocking. However, since having to come back to lockdown, I've left it in Plymouth, so unfortunately wasn't able to implement that. But now you can see that I've unlocked the door 4 or 5 times now. So if I go back to the web page, you'll be able to see on my dashboard that it's updated to 6 times today, and the time is now updated to 8:04, and the graph, etc., is updated with it. So yeah, that essentially is the functionality of the door lock. So if someone that was unknown came up, it would say unknown, as well as one of my trusted users will also be able to get it to print door unlocked as well. So now if I go back to the web page, so as you can see, FaceLock I think is quite a well-rounded application, and all of the objectives that I'd set myself have been completed. And this was just an example demonstration of what can be done with it. So I think this is a good place to conclude my video report. Yeah, I hope you enjoyed. Thank you very much.